All right, welcome again. Mic check looks good. I want to say good choices, but it's just so hard to say that confidently. So, anyways, what I just it's always a good choice to do something that you like doing. So I'm gonna finish up this lab. Just making this lab. Um, so let's do that. And I did all the hard work in the last video. This is the Automate Your Network series. I picked out. I did like the hard architecture work. Um, all I have is the 10 gig capable devices. In your core, you need 40, 100, basically as much as as your budget allows. Um, so, and then even if your budget doesn't allow for it, you just as much as you can get in the core. It's the core. So this is not. It's just a lab. So yeah, I've got my core network built out. And I've got it built out with the Nexus 9500s. It's definitely overkill. You'd want to use Catalyst devices because they they cost a lot less. Um, in the campus, you'd want to use a Catalyst device. So in the campus core. All right, so let's continue building this out. So each of these. So here's what the network's actually going to look like. We've got the core layer, and then we've got different kinds of like modules or like sections of the network. We have just the basic office building or like office floor sections with the distribution and the access layer. Then we have the data center, which I mean we looked at this too in the last one. I was kind of surprised that the data center didn't come in through the WAN, but this looks like a special case network where the data center is in the same building or like is geographically or in a building in the same geographical region, so it can plug into that core. So we're gonna go with that and have it hooked up that way. And then you've got your internet access, your WAN access. So we're just gonna have it look that way. So here's the core. Now we gotta pick out the distribution switches. Now we had a discussion with the AI to help with the network architecture to pick out the distribution switches. So I would like to pull that up again. I forget where it was. I prompt the AI like all the time, like every day. Like probably there hasn't been a 8 hour, there hasn't been a 12-hour period in my life since this was released where I did not use it. I would say, which is why I'm paying for it. All right, so let's uh yeah, so let's try to. So this was file load assistance. Is this it? Uh, I had like a huge, yeah, this is it. So I had like a huge conversation with it, and it drew me out diagrams, and it was like really useful. So there's one part of this conversation where they like picked out what devices they want me to use for the lab, and by they I mean the AI. Um, so I thought those were like pretty good choices. So let's go with that. I thought I could just plug in a different module too, and get different link speeds, but that's not the case. So of the image files I provided, they did select a few for the core. I just couldn't tell what link speeds these were capable of. Uh, I think it was the extreme where I couldn't tell. Let me actually do some quick reconnaissance on this. Okay, so let's get the Arista out. Alright, we'll get that right there. And then let's get the Extreme out. Okay. We'll start them both. Let's try to look at the... Now, we're talking about the core here again. I'm done with the core. We've got our 10 gig links in the core. So we're going to pretend, this is the 80s, put on some synth waves or something, and just go with that. But I think just checking this is fine. So I think I asked it... yeah, so, okay, yeah, here it is. So here it picked it out. I mean, this is the one it picked out for me. Distribution is picking out the Aristas. Access, it's picking out the Arubas. Yeah. And I don't know what it's doing for the data center. Oh, for the data center, it's saying it's not actually having a data center. So let's do this. So instead of using a generic CentOS image to represent the data center, could you please design and architect a data center network? Here are the image files you will have to work with in GNS3. Act as a CCIE data center act as a CCIE data center architect. Alright, so then let's see here. So here are the image files you have to work with. So it should be up. Yeah, here we go.
Below is a high-level overview of the components and their roles. Core layer core switches suggested image file. Nexus 9500B. 9.3.3. Keep out to reason. Cisco Nexus 9000 series switches are commonly used in data center core layers due to their high throughput and advanced feature set. Role. These switches will form the backbone of the data center, handling high-speed packet forwarding. Aggregation layer aggregation switches suggested image file. Aruba OSCX disk image generic x86p 420,210,316,185,909.
They want an access center aggregation.
Aruba switches can serve well in the aggregation layer, offering a good balance of performance and features.
Wait.
Role. These switches will facilitate communication between the core and access layers, providing a consolidation point for
Is
traffic.
that what they want?
Access layer access switches suggested image file. BIOS_L2 Adventure Project INM. 2017. Keep out to reason. Cisco's iOS VL2 images are suitable for simulating layer 2 switch functionalities. Role. To manage traffic at the access level, providing connectivity to servers and other end devices. Compute resources servers suggested image files. Ubuntu % 2020. 04% 20, 64-bit. VMDK for Ubuntu SERVERSCENTOS8 generic cloud -8. 4. 2105-202-10603.
Why have 3 distinct layers for core aggregation and access? Don't data centers typically only have 2 distinct layers? What the...
You're absolutely.
Oh. Yeah, do that
Correct.
instead.
Many modern data centers have adopted a simplified 2-tier architecture, which merges the core and aggregation layers into a single tier, often referred to as the spine leaf architecture.
That's what I had.
This approach has several benefits over the traditional 3-tier design, including reduced latency, enhanced performance, and a simplified design that can easier management and troubleshooting.
I have that right here.
Spine leaf architecture spine layer core switches suggested image file. Nexus 950B. 9. 3.
Ow. This
Keycap
is
to
a
roll.
Cumulus Linux.
Serve as the high-speed backbone of the network, interconnecting all leaf switches. Leaf layer, access, switches suggested image file. Aruba OSCX disk image, generic x86p 420
let's
trillion
ask
210 billion 316 million 185,000.
Okay, great. Thank you. What about this image? Does this make sense to use as a leaf device image?
Yes, using. The Cumulus Linux 4. 2. 0BXAMB64
Okay, yeah, let's do that.
QCOW2 image for a leaf device makes sense and can be a very good choice.
Oh,
Cumulus
thank you.
Linux is an operating system that focuses heavily on network
Appreciate
design,
it.
particularly for data centers.
Appreciate
Here are some
it.
reasons why it is a strong candidate. Cumulus Linux in a leaf-spine architecture 1. Flexibility and scalability.
Okay,
Cumulus
we're
Linux
going
supports
with
a wide
that.
range of hardware
It's already
platforms,
there.
which allows for a high degree of flexibility when choosing hardware. It facilitates easy scaling. Adding new leaf switches is straightforward, promoting hassle-free network expansion. 2. Network virtualization. Cumulus Linux supports various network virtualization technologies, which can be beneficial in creating isolated networks in a data center environment. 3. Modern technologies. It supports modern data center technologies such as VXLAN for overlay networking and EVPN for control plane operations, which are key in modern data center architectures. Enables automation and infrastructure as code (IAC) approaches, facilitating network management and configuration through automated scripts and tools, reducing the chance of human error and improving operational efficiency. 4. Integration with DevOps tools. It integrates well with popular DevOps tools, promoting a streamlined workflow for network management and operations. Compatible with a variety of automation tools like Ansible, Puppet, and Chef, which can be instrumental in managing configurations and ensuring system state across a large number of devices. 5. Web-scale networking. Cumulus promotes web-scale networking principles, which are designed to bring the operational model of large web operators to a broader audience, facilitating high efficiency and flexibility. Considering the above points, the Cumulus Linux image is indeed suitable for your data center design, serving as a leaf switch in a spine leaf architecture. It would be a modern choice that aligns well with current best practices in data center design. Would you like to proceed with using Cumulus Linux as a leaf switch image in your GNS3 simulation?
Yeah. I'll just have core there. Okay, now let's build out the other parts of the network. So we just got like generic stuff. Then we got the WAN and the internet one. So let's drop that. So internet. What's really cool is like I could have my server be like on the network or like wherever I want it. But let's have the internet over here. Actually, let's have it at the bottom so that it looks like the what's given in the drawing more. Okay, and we could just delete all these devices. Yes, I would. And this one too. And this one. And this one. Yes, please. Please delete them all. Yeah. Go ahead. Okay, how do I access these? There we go. Delete all these too. Yes, delete all 12 of them. Might as well just delete the WAN as well. Okay, so this is a pretty good spot now. We've got the data center here. We've got the core. So the data center is its own thing. Kind of a weird setup. It's plugging directly into the core. But not so we need 10 gig links from the data center for sure here. These have to be 10 gig. What kind of devices are these again? Okay, these are the Nexus. So we've got our 10 gig there. That's what we need. We definitely need 10 gig between the data center and the core. Definitely. Okay, so then let's do our internet. We'll do the WAN and let's do the internet, and then we'll do the WAN next to it. So I'll drop another one of these, and then we'll call it WAN. All right, and then we need so we need some distribution switches, and then let's go with what the AI suggested. So for the this is the data center architecture. Oh wait, no, wait. Yeah, this is the no, this is the wait, I'm confused here. Oh, I see. So here's okay, here's what I need. This is the um oh, they're architecting a data center. So yeah, this is not what I need. Don't architect a data center, please. Yeah, so yeah, here's what I did at first. So yeah, we got our core set up. Now we need our distribution switch. We're gonna use a the VEOS. This is the Arista. We're gonna use that. So yep, Arista VOS. So that's the distribution. Um, and then we'll have another box for that. Oops. See, this is what I hate about GNS sometimes. It doesn't make it clear like how many things are selected at a time. And sometimes it's easy to accidentally select too many things at a time. Okay, so here's my internet network. So we need the distribution switch for that. Yeah, and then we need the for the internet, right? Which one is the? I mean, we can just use it for the same for. Well, I guess we can't. I don't know. I'm confused here. Oh yeah, these will have this is what we need is this diagram right there. Okay, so perfect. Okay, so we have the core layer. Now they're saying to use. Oh no, it's all like messed up. Like the access layer should be up here. This whole belongs to an access layer. The core layer can be the nexus, and then so the aristas at our distribution, it's going to be the same. Yeah, they're using Arubas and okay, yeah. All right, so it looks good. So now we just need to drop a bunch of aristas for the core layers, for the distribution layers for each of our sections of the network. So we need 4 of them to be dropped. 2 of them go to the WAN, and then 2 of them for the internet. Okay, so that's the core. Oh, this is internet. That's okay. Let's label it internet. Okay, so we've got it's labeled internet. Now we gotta change the host name on this to call it. I mean, I don't know what it's called. We can call it like dist. We can call it like int dist 01. Okay, and then here we got the other one. Int dist 02. Okay, got it. All right, so now we need this is out to the WAN. So now we need our leased line to connect into something. We're gonna have it connect into this router iOS image. So we're just gonna get a 1 gig leased line connecting into there. Oh, and that's the WAN. What is it for the internet? Oh, for the internet we need our firewalls, but we'll still need those same devices. So let's drop 2 of those. Okay, and then we're gonna call it int access 1. Yeah. So int access 01. Okay, looks good. Int access 02. Okay. All right, and then we need to pull this down. All right. And these go right to the edge because we're gonna have those firewalls in between. All right, now let's drop our redundant firewalls there. So let's see what the AI picked out for that. It picked out a Fortinet. Let's use that. Now we've got a FortiGate here. What was the Fortinet? Is that the same? Let's go back up to, yeah, here we go. So they want the FTG. Which I think is, I think it's this one, right? Yeah, it's this one. Okay, so here we go. Here's our 2 firewalls. So we'll call it int fire 01. Or we could just call it firewall, but we'll do int dash. Change host name. Int firewall. Let's do the whole thing. 01. Okay, and drop another one. There we go. 02. Looks good to me. Oh, and then we had see how it gets annoying sometimes. But yeah, that looks good to me. Yeah, I'm pretty happy with this right now. Okay, yeah, that looks great. That looks wonderful. So the next step is, let me just put this kind of more where it belongs, like up here. Okay, and then we want the WAN segment of the network. Okay, we've got the WAN segment of the network. So we'll call this WAN. WAN. There we go. And just like for everything, we need our distribution devices. So those we decided on using. I forget. I can check it really easily. We decided on using EVOS devices. So yeah, Aristas. I remember now. So we need 2 Aristas. So we'll call it WAN dist 01. And then, yeah, we can call it WAN dist 02 for this. It automatically selected it, which wasn't so good, but it's working out. Okay, so now for this one, we're not going to have any firewalls. We're going to have just the same devices to get the leased line. So we'll call it WAN access. Okay. And then we'll call this WAN access 02. All right, looks good to me. All right, now we need another segment of the network, and that's just going to be these plug and play, floors of the building, what have you, different building sites. I mean, typically, my understanding was that these all of like everything on this diagram would be in one building, but obviously that's going to be tricky with the data center unless you have like the data center in the basement or something. But my understanding was that all of this is in one building. I don't know if my understanding is correct. I could ask the AI. Let me ask the AI. So my understanding of all of this is that everything is going to be contained within one building. Is that a accurate understanding, or would a lot of this equipment be contained in multiple buildings in the real world?
In a real world scenario, network architectures can vary significantly based on the specific requirements, scale, and design principles of a particular organization or data center. Here, we outline 2 common scenarios. 1. Single building, on-premises data center. In the setup, all the network components, including core, aggregation, and access layers, as well as servers and storage, are housed within a single physical location or building. This is common for medium to large enterprises that operate their own data centers.
Yeah, which is what we're simulating.
Pros. Control. The organization has full control over the physical infrastructure. Latency. Reduced latency as all components are in close proximity. Cons. Space constraints.
And cloud
limited by the physical
is
space available
be...
for housing the equipment. Disaster recovery. Concentrating all resources in one place can be a risk in terms of disaster recovery. 2. Multiple buildings, campus network or multi-site data center, and larger enterprises or cloud providers. The network might span across multiple buildings or even geographical locations. This is often seen in university campuses or large corporate offices. Pros. Scale. Allows for a larger scale of operation by utilizing multiple physical spaces. Redundancy. Provides greater redundancy and resiliency by distributing resources. Cons. Complexity. Managing the network becomes more complex with increased points of failure. Latency. Potential for increased latency due to the greater physical distances involved. Hybrid and cloud solutions. Apart from the above, many organizations today leverage hybrid solutions, utilizing on-premises data centers in conjunction with cloud solutions, like AWS, Azure, or Google Cloud, to optimize costs, scalability, and performance. Colocation facilities. Some organizations opt for colocation, where they rent space and resources in a third-party data center, which might be one of many tenants in a large data center facility. Final thoughts. So, while your GNS3 simulation might represent a single building setup for simplicity and learning purposes, real-world implementations can indeed span multiple buildings or even be distributed globally, leveraging a variety of modern technologies to maintain connectivity and ensure optimal performance. Would you like to reflect a specific setup in your GNS3 simulation, or continue with the single building model?
Okay, yeah, it's a single building. It's just got like a lot of different floors on it. It's got a whole data center. It's a big tradition. See, the thing is, like, I want to get away from like trad office style setups, and I want to learn about like networking that's relevant to like all remote workers. So like that would be like all cloud, which I'm trying to get into. I think that's really important. Like this is a tangent, and I probably should be saying this, but I honestly believe that like cloud is now, or like going to be in the future, like just what networking is. Like there's no such thing as networking that's not cloud networking. Like, yeah, there's hospitals, there's stadiums, like there's big buildings that have their own networks, but it's like my understanding of cloud is like it's just somebody else's network. So it's like a cloud network, like hospitals. Let me ask you this. So when it comes to cloud networking, what are some examples of modern day networks that are not cloud in any way imaginable? For instance, in my own mind, I would think that a hospital or a stadium would be such an example, because they would own all their own network equipment, and all of their stuff would be on premise. Is this a fair understanding, or am I misunderstanding some critical concept? If so, then what concept could I be misunderstanding?
You're on the right track in identifying that certain environments, like hospitals or stadiums, might primarily rely on on-premises infrastructure. However, it is becoming increasingly rare to find environments that use no cloud services at all, given the various benefits cloud services can offer.
Exactly.
1. Traditional on-premises networks. In traditional on-premises network, all the network resources and services are housed within the organization's global infrastructure. This is commonly seen in environments with high security and control requirements, such as
aren't going anywhere.
Hospitals. Due to the sensitive nature of medical data, many hospitals opt for on-premises data centers to maintain control over their data. However, many hospitals also use cloud services for various applications, including electronic health records, EHRs, and telemedicine services. Government institutions. Many government organizations maintain on-premises networks to safeguard sensitive data. Manufacturing facilities. These might have legacy systems and machinery that are not compatible with modern cloud solutions. 2. Hybrid networks. Hybrid networks utilize a mix of on-premises and cloud resources. This is a common approach for organizations transitioning to cloud solutions while still maintaining some on-premises resources. 4. Banks and financial institutions. While many have adopted cloud solutions for scalability and efficiency, they often retain critical data on-premises to maintain control and comply with regulatory requirements. Educational institutions. These often employ a hybrid approach, using cloud solutions for collaborative tools and learning platforms while retaining on-premises networks for sensitive data storage. 3. Cloud networks. Cloud networks rely heavily on cloud services for data storage, applications, and even networking through services like OSVPC or Azure Virtual Network. Many modern startups and tech companies opt for cloud-first or cloud-only approaches to minimize upfront costs and benefit from the scalability and flexibility of cloud services. Concepts to consider: security and compliance. Organizations in regulated industries may have stringent security and compliance requirements that dictate the use of on-premises networks. Legacy systems. Older legacy systems might not be compatible with cloud solutions.
When it comes to the value of a worker as somebody trying to get a job in this sort of stuff, is it fair to say that the only real way to get real value in terms of a high salary and in terms of a job with a lot of flexibility to work where and when is best for you, you have to learn cloud, and there's basically nothing else besides cloud that can provide this when it comes to the networking space?
In the current ID,
And this
landscapes
is
have knowledge and experience with cloud
2021.
technologies can indeed be a significant asset when seeking high-paying roles and flexible working conditions.
Yeah.
Cloud technologies are at the forefront of the industry, powering many modern applications and services. However, it is not the sole pathway to a valuable and rewarding career in the IT
security
field.
and AI, but
Here's how you can look at it. 1. Cloud computing pros. High
this
demand.
is
Many organizations are
garbage.
migrating to cloud platforms, creating a high demand for cloud professionals.
Yeah.
Remote work opportunities. Cloud roles often allow for remote work, as the infrastructure is accessed over the internet.
Exactly.
High salary. Cloud professionals can command high salaries, especially those with certifications from major providers like AWS, Azure, and Google Cloud. Cons. Complexity. Cloud environments can be complex, requiring a deep understanding of various services and integrations. Continuous learning. Cloud technologies evolve rapidly, necessitating ongoing learning. 2. Traditional networking and IT roles pros. Foundation knowledge. Understanding traditional networking concepts is foundational and still necessary in many environments.
Yeah, but
Roles in
not
various
to a
industries.
large.
Many industries rely on traditional IT infrastructures, including government, healthcare, and manufacturing. Specialization opportunities. There are opportunities to specialize in areas such as security, which remain critical in both cloud and on-premises environments. Cons. Limited remote work. Some roles may require physical presence to manage on-premises hardware.
Exactly.
Potentially lower salaries. While there are still high-paying roles in traditional IT, the highest salaries are often found in emerging technology areas, including cloud computing. 3. Hybrid skills. Professionals with skills spanning both traditional networking and cloud technologies can be particularly valuable, able to work in hybrid environments and facilitate migrations from on-premises to cloud infrastructures. Conclusion. While cloud knowledge can be a pathway to high salaries and flexible working conditions, it is not the only pathway.
Yeah.
Professionals with deep expertise in networking, security, and other IT disciplines can also find rewarding roles. Moreover, cloud computing often builds upon traditional networking concepts, so having a robust foundational knowledge can be a considerable asset. The key is to remain adaptable and committed to lifelong learning to navigate the evolving IT landscape. It might be beneficial to explore certifications and educational pathways that align with industry demands to foster a lucrative career. Would you like advice on potential career paths or educational strategies?
Yes, please give me that advice.
Absolutely. Here's UING. A career in networking, whether in a cloud-based role or a more traditional IT position, can indeed be a rewarding choice. Here's a general guideline to help you strategize your career path. 1. Building a strong foundation. Certifications. Consider starting with foundational certifications like CompTIA Network Plus, CCNA, Cisco Certified Network Associate, or Juniper's JNCIA Junos. Hands-on experience. Try to gain hands-on experience through internships, freelance projects, or lab environments like GNS3 that you're using.
I need to do more
Programming
freelance.
skills. Learn basic
I don't know
programming and
how to
automation
do
skills.
freelance.
Python is widely used in the network automation field. 2. Specializing your skills. Once you have a solid foundation, you
I
can specialize.
thought I had basic Python skills, but I guess I don't. I don't know how. See, this is why I want that PCAP. Because it's like, I just learned Python by accomplishing things. Like, I don't know any algorithms. Like, I never really drilled on the, leak code and all that. Because I used it for, like, what I needed it for. And I didn't need it to, like, write a bubble sort algorithm. Like, it already has stuff like that in the standard library. So, like, I would just use, like, the libraries that I needed. Shoot. Oh yeah, here it is. So it's the which one is it? Oh yeah. These make a lot of sense, I think. This one especially. Like, I'd love to work in data analytics, but it's just, I think that's just too much of a pivot. Like, this makes so much sense. And this is the kind of one where, like, I should just take it now, because what's going to happen if I just take it now is, like, I'm either going to pass it, which is like, oh, great, that's wonderful. I'm validated in my skill set, and I'm worrying about some stuff for nothing, and I just need to spend like literally just a few hours doing leak code problems. So, like, that would be good. Or I fail it and it's like, oh, I'm a complete idiot at Python. So I just want to know, like, how good am I at Python? I have no idea. Because it's like saying, how good are you at reading and writing in English? It's like if you're not even aware of, like, what PhD academics do when it comes to, like, reading and writing, it's like, yeah. So this one makes a lot of sense. I'm getting off task. I need to be I want to be building this out. So yeah, well, you know what? I wasn't so off task. We just needed to figure out what this building looks like. So, it looks like this. We have our core connecting to the internet and WAN segments of the network, and then we have the data center. So we need one more part, and we'll put that down here. So we need a box for that. Okay. Oh, and see, this is what is annoying about GNS. There we go. Okay, so we need a box for this. And we'll call it like floor 1. Or like first floor. So yeah, we'll call it like floor 1 dist. So we just need the same devices. Well, we do need an edge though. It's not going to be exactly the same. We need a different edge. But our aristas are the distribution devices. And then okay, so yep, and then we need an access. We actually need a real access switch for this segment of the network. So we're gonna use an Aruba for that. And is it the CX or is it the, which one is it? Let's see here. They're probably both the same. We're gonna use the yeah, the 1909 5909. I'm not sure which one that is. I don't think it's this one. Oh, it's this one. Well, what is this one then? I'm kind of curious about that. But before I let my curiosity get the best of me, let's build out this. Oops. There we go. And then we can have some like workstations for, and this is like in an office, so like usually like CentOS machines are like used. So we can have 4 of those. And there'd be like machines here as well. Like we'd use like, server machines here. But these are just for like workers. I mean, this is an office building is the thing. It's like I don't want to, like, I'm done with office buildings. I want to learn. Okay, let me ask the AI. So it appears here that all of this is about an office building. I'm really not interested in office buildings because I just really don't want to work in an office for the rest of my career. I'm only interested in 100% remote work. So if I'm currently a network engineer and I'm trying to transition my career to things like cloud because I want to work remote, what are some things I could set up in my lab besides this thing that we're working on now that represents office buildings that I don't really want to be a part of in my career? What are some things that will really excite me to build networks for as somebody who wants to work location independent?
Absolutely.
Exactly.
Focusing on skills and setups that align with remote work and modern cloud technologies is a wise approach. Here are some ideas and technologies you might explore in your lab to build skills that are highly relevant to remote work opportunities. 1. Cloud environments. Explore and set up different cloud environments that allow you to familiarize yourself with widely used platforms.
No, I get this,
Oz,
but
Azure, and Google Cloud. Set up
it's
and
not
manage
playing
virtual
along.
servers, databases, and networks in these environments.
No, I understand what I need to learn. So I understand what I need to learn, but what I want to understand is like, shit. Come on, stop this. No, I understand what I need to learn and what skills I need. What I don't understand is how do I apply these skills? I know one of the ways to apply these skills is to make it so that workers inside an office building can communicate with each other, or people inside a stadium can communicate with each other. But these are the sorts of things. And another example is people inside a hospital where they're not location independent. They're people inside buildings working together. I'm really not interested in those kinds of scenarios. Please tell me a real world scenario where you would need something like cloud networking, but for a situation that did not depend on location. Basically, the magic of the internet, in my opinion, is that we can communicate with each other over geographical bounds. So I want my job to reflect that. I want my job to be done over geographical bounds. I want to do business with people on the other side of the planet.
Absolutely, leveraging cloud.
Yeah, okay, that's good. That's good. E-commerce, that's a good one. Telemedicine, that's a good one too. Okay, those are good. Online, yeah, online education, virtual classrooms. These are good answers. That's a good one too, is like a tools platform, like making the next like Slack or like Agile, tools that can be used in any way. Decentralized finance, that's probably a good one too. Cool, that's a good one. Thank you. Those are all really great answers. That's exactly the kind of thing I was looking for. Are you able to list any more besides just these 6?
Absolutely, I'm glad. You found those suggestions helpful. Here are a few more.
Oh, yeah, that's a great one too. I love VR. I used it like every day during the pandemic. Yeah, that's so great. Diagnostic, repair. Oh, that's a good one too. I've actually thought about this one a lot, kind of like a worldwide help desk for like anything. Like here in my city, we have a 311 you can call. So like I want like a worldwide 311. Which, I mean, we kind of have that with like the internet. Like you can go on Google and like, how do I fix my door handle? But like what they're going to do is like show you Viagra ads and like redirect your attention to like a door dance or something. And like, you're not going to, so like if you can just call and like actually talk to a person and like focus on getting the task done, I think that'd be pretty valuable. Okay. Yeah. This would be great too. Oh, this would be wonderful. This would be absolutely amazing. Distributed research. Oh, I love that. This would be, legal. Global. Oh, this would be a good one too. Kind of like BetterHelp does that. Well, let's ask about that. So regarding number 12, there's a platform called BetterHelp. Can you please write out for me a problem or some sort of job post that they might have for somebody learning about the kinds of things we've been discussing during this conversation, can you architect a network that would be useful for this company, BetterHelp?
Absolutely. Here. That's how a job post for a network architect at a telehealth platform like BetterHelp might look, along with the responsibilities and the network blueprint they would potentially work on. Job posting. Network architect at BetterHelp company. BetterHelp position. Network architect location. Remote about BetterHelp. BetterHelp is the world's largest e-counseling platform, facilitating online therapy sessions where users can connect with licensed and
It's
accredited psychologists,
e-commerce.
marriage and family therapists, clinical social workers, and board licensed professional counselors, all from the comfort of their own homes. Responsibilities. Design and implement a secure and scalable network infrastructure.
Where?
Develop a
Why?
cloud-based network architecture to ensure secure and reliable connectivity for therapists and clients. Implement DDoS protection and other security measures to safeguard user data. Optimize network.
Where and why would you develop and implement secure and scalable network infrastructure? I mean, all of these people are at home through home internet connections. Are you just going to run a special private link out to every customer's home? I mean, what are we actually talking about here when we say to design and implement a secure and scalable network infrastructure? Are we talking about standing up our own internet service provider? What is this?
Creating a secure and scalable network infrastructure doesn't entail setting up a private link to every customer's home or becoming an internet service provider.
What is it then? Tell me.
Instead, it refers to creating a network infrastructure where the services and applications of BetterHelp are hosted and managed in a way that ensures security, privacy, and good performance.
But it doesn't have
Here's
any
how and why you would know about this.
services.
Where? Cloud providers. Utilize platforms like AWS, Azure, or Google Cloud to host the core infrastructure.
The people
These
are the
platforms offer robust and
services.
scalable solutions that can be tailored to meet the specific needs of a telehealth service. Content delivery networks, CDNs. Utilize CDNs to distribute the services content closer to the users, reducing latency and improving.
But it doesn't have any services. The people are the services. The therapists access it from their home as well, don't they? Or do they go to some special BetterHelp office with special BetterHelp networks? I just don't understand what a network is for or where it would be deployed. Like, what are we actually talking about here? Are we talking about like hosting the website for BetterHelp? I guess that makes sense if we could host the website using some kind of cloud service. Is this what we mean? What other aspects of this am I failing to think about? Please create a design and architecture for this company, BetterHelp, and please be very specific about what real world things are needed for what real world requirements for those things.
Certainly, creating a robust and secure network infrastructure for a teletherapy platform like BetterHelp involves considering various components.
Okay.
Here's how you can architect the network infrastructure. Infrastructure overview,
Yeah,
website
you'll need
hosting, and application service cloud
databases,
service
right?
provider.
Yeah.
Oz, Azure, or Google Cloud for hosting websites and
Payment.
backend services.
Payment.
Databases. Secure and encrypted databases to store
Okay.
user profiles, therapy session notes, and other sensitive data. Content delivery network, CDN, purpose. To cache data content closer to the users, ensuring low latency and high availability. Provider. Services such as AWS Cloud for Akamai. API service purpose. To facilitate the integration of BetterHelp services with other platforms and services like payment
Okay,
gateways,
that
SMS
kind of makes
gateways, etc.
sense. Yeah, that's
Closing parenthesis. Security. Implement API security best practices including OAuth for authentication.
All right, now it's starting to make sense. You need the customers to pay. You need them to connect to each other. I guess they could just use Zoom, but that's what you're offering is the secure platform with like you're basically creating your own Zoom, but it's secure, it costs money, and you can contact a specific kind of person when you use it. Like that makes sense. Like Zoom needs to have databases to store the profiles. Like, okay, this actually makes a lot of sense. This makes a lot of sense. Okay, everything makes a lot of sense right now. Cool. Well, with that, I think since things are making so much sense, and I've got my network ready to go, we can delete this box down here. So the next step is cabling. Oh, and this needs a label. Oh, and everything here needs to be labeled. Let's take care of that before closing it. But we're definitely making some really good progress here. And for some reason, I can't move over. Okay, so we'll duplicate this. There we go. We'll call it. Now we're simulating an office building, which, as I mentioned, I want to get away from. I wish we could simulate instead like better help. We could have this be better help, and then, but the thing is, like, we wouldn't, it would be an e-commerce site. Design and architect a network for an e-commerce site.
Designing a network for an e-commerce site involves establishing a robust, secure, and high availability infrastructure that can handle a large number of transactions and user data securely.
Yeah.
Below is a high-level design and architecture of a network for an e-commerce platform. Infrastructure overview: website hosting and application servers. Cloud service provider. Utilize AWS, Azure, or Google Cloud to host the website and backend services. Databases. Set up databases with strong encryption to store user profiles, order details, and product information. Content delivery network, CDN, purpose: to deliver static content quickly to users by caching it near their geographical location. Provider. Services like Cloudflare, AWS CloudFront, or Akamai can be employed.
Yeah.
API servers. Purpose: to integrate the e-commerce platform with other third-party services such as payment gateways, shipment tracking, etc. Security.
Okay, it's making sense to me. It's all making sense to me. So complicated. All right, so yeah, we're gonna delete this one. Yes. Oops. It looks like I deleted the whole lab. I'll try starting it again, and hopefully I can get that back. Hopefully none of. We'll see how much of it was lost. Looks like all of it was lost. Yeah, pretty much all of it was lost. Oh no, there it is. Okay, good. So okay, we're good. Yeah, now let's just change all this labeling, and then that will be that. I'll stop the video and I'll do cabling in another video. So text edit. We're gonna call this floor 1. Floor 01, and then we'll call this so apply. Okay, and then we're gonna change the host name here. Floor 01 dist 01, and was I doing a dash? Yeah, I was. Yep, looks good to me. And then this is a dist as well. All right, and then we've got access. Okay, there we go. All right, there we go. And now we've got our workstations for the employees at this company. Now, every employee in this company is special. We celebrate their humanity. They are a human being, and we treat them as such. So we're going to call this person P57452. Nobody at this company is just a number. They're a complete person, and we celebrate their humanity. So P57452. Here is your laptop. The P stands for person, because we're people. We're people company. Okay, and then we'll call this one P, to just mash the board, because that's how much we care about this person. And then we'll do that for all of them. We'll just put it in a spreadsheet or whatever and just assign them random numbers. All right. Okay. All right, so here's our beloved, cherished, unique employees that we really you know we really feel grateful for having them here. So um, uh, let's go ahead and close it out. We got everything. We got everything. So we'll do the cabling in another video. For now, I wish I could move around. Why can't I move around? I used to be able to. How do I move around? Maybe this whole thing needs to come down a little bit. Okay. Yeah, that's better. I can't move around the way I used to. Like actually, how do I move around? I thought. Okay. Well, anyways, yeah, we've got everything labeled good. So, yeah, that's it. Stay tuned for the next one where we do the cabling. Let's drop a few. Let's drop a few. Well, we can do that later. We're fine. I was gonna drop some like servers in the data center, but we're good to go. So that's it for watching. And stay tuned for the next one.